introduction, so I just make a few. He's the director of the Humanoid Robotics Institute, Waseda University, Japan, which is the first humanoid robot lab in the world, founded by Professor Ichiro Kato. He has also served as the president of Japan Robotics Society, among many others. Professor Takanishi especially dedicates his research to the application of humanoid robot for medicine and well-being, and much more. In addition to his achievement in academics, he is also a very good drummer. When you can control the stick of a drum, you can control the leg of a humanoid, then the entire humanoid. Let's welcome Professor Takanishi.
Thank you very much. Okay, today I'm going to talk about a kind of history of my research, especially on human robots and its application. Some of the technology already distributed to our society, commercialized. And by the way, I'm wearing two types of watches. One is a current one, electrical watch, electronics watch. Maybe many of you already have. By the way, this is a totally mechanical watch. Have you ever seen this?
Yeah.
Okay, this watch doesn't need to wind. There is an automatic winding mechanism inside. That's an invention by Seiko. Yeah. So there is a small pendulum inside, and either way, the pendulum winds the spring. So this was a huge sales to all over the world. After even now, many companies who are more interested in mechanical watches, like in Switzerland, still making this watch. Of course, this is also Seiko's watch currently produced. So I'm a mecha crazy. So maybe I'm going to show you some of them. By the way, I'd like to introduce many of my colleagues. This Dr. Professor Jayu Lee. She's there. She's mainly doing research on medical things. And then also female young colleague. She's Nakazawa, and she's now making a pitching robot. Shohei Otani. Yeah, we want to make a Shohei pitching robot like this. She also very good at designing mechanisms. Not like the other humans nowadays. They are using QDD motors, actually electric motors. Of course, this robot uses electric motors, but also uses sort of spring mechanism that can charge potential energy. So in many human sports, there is a sort of energy transfer from potential to the kinetic energy. In this case, the ball speed. And this is a recent result, like this. So at this moment, this robot doesn't have a lower leg, but if the lower leg was made, the final speed is calculated about more than 100 kilometers per hour. So this is what this kind of can do, much faster than actuator speed. Okay, this is also this is a Chinese guy. He has been doing research on axial leg for entity, and of course it's more intelligent and adding more function in order to fit each amplitude's motional specification. This is Professor Ichiro Kato, my advisor, who died in 1994 by some kind of accident. So he developed many different types of human-related robots. But those two robots are very famous. The Robot 1, which stands for Waseda Robot, completed in 1973. He started to develop this robot in 1970. And this robot has like this 2 legs with upper body and 2 arms and no head at this moment. But you can see there are white dots on the center of the body, torso. Those are cameras. Of course, not the semiconductor, but vacuum tubes. You see, and the computer, of course, very large. The outside of the robot, using Hitachi High-Tech 10. Its memory size is only 64K and 16-bit CPU. This robot can recognize the human voice and generate human speech. That means the robot can communicate with humans. I believe historically the first time humanoid communicate with humans. And the robot has 2 legs. The speed is something like 45 seconds to 1 minute for 1 step. Step length was also very small, 10 centimeters or something like that. But at that time, a professor in the same department, mechanical engineering, told him, stop this kind of stupid research because 2 legs machine made by iron would never work. So because of that pressure, he struggled to realize this kind of result. About 10 years after, he developed the Robot 2. The robot does have 2 legs, but not for walking, but for playing the electric organ like that. At that time, this was called the Yamaha keyboard. And the camera on top of the robot, you can see. At that time, the camera, the sensor was semiconductor, but only array, 1 line, 2048 cells, no color. And there is a stepping motor, scan the image. So speed is very, very slow. But this robot really read the commercially available musical score, then recognize the musical scores to generate more motion of the arm and fingers. And after that, this robot was, the copy of this robot was called Wasco, which was displayed in the Tsukuba Expo 85. By the way, why humanoid? So the first one is Professor Ichiro Kato said, at that moment, it's almost impossible that the human will be useful for our society because of the lack of technology. But making of human machine give us a lot of understanding how human is being made. So this is a very important point. Nowadays, because of human rights, you cannot easily use human for experiment. Europe, the US, maybe other countries, including Japan, are using human in order to analyze human, especially for use of related to medicine and welfare. The second one is, because of this, we can obtain a very important human model in terms of engineering. This is also important. Even your seats and everything in this group is designed by engineers. And if the engineer has a human model to design your seats, maybe much better seats can be designed, combining the former technology about mechanical engineering with human robot, humanoid model, human model. So finally, making of a human robot is a sort of grand challenge. Something like Apollo project, the United States in the 1960s. By the way, when I was a primary school student, I watched a human was landing on the surface of the moon. So that was a very big shock for me. Then after that, I really decided to enter to be engineer. So, but anyway, making of human is something like that. So after that, I'd like to show you some of my, not recent, but after Kato's robot. This is a bipedal human robot, as you can see now everywhere in the world. This is called Wabian 2, which stands for Waseda Bipedal Human. And not like the current or other type of humanoid, this robot has degrees, some degrees on the pelvis. This makes the robot walk like human. Many human robots is always bending the knee like this. Do you know why? This is avoiding of singular position, the knee joint. But actually human is moving the pelvis in order to do that. So this can avoid such kind of singularity. And also, we, at that time, 2003 to 2006 or 7, we also designed the robot based on human anatomy. For example, the ratio of the length, the upper body, upper arm and forearm, shank and thigh, they're almost same as human anatomy. And also mass distribution is also about the same as human. So still now, I believe this humanoid is the most human-like humanoid in the world. Please see how the robot works. You see, the robot moves the pelvis and fully extend the knee while walking, like humans. And if the outside surface is really smooth, the robot still can walk like this. Because there is a sort of stability control. And also, this is a big finding. So we have been collaborating with a researcher in human science or rehabilitation. So they told us why this is a flow reaction force while human is walking. So especially the vertical component has two peaks, only for human, but for chimpanzee or gorilla only have one peak. Why? This is evidence that the robot fully extends the knee while walking. Because on the right upper side, this is a flow reaction force of the Wabian that mimics the, Asimo. Do you know Asimo robot? Yeah, the robot is working always like this. So the reaction force has no peaks. But Wabian 2 has two peaks, like human. This is, I believe, very important. After that, we try to make a feet narrower to be similar to humans. Because we wanted to collaborate with Adidas at that time. Adidas had a special contract with Waseda, but they refused. Why is that? Japanese branch doesn't have any right to do such thing, just a distribution to Japanese market. That was very unfortunate. And by the way, we collaborated with Hitachi. Hitachi, in the beginning of the 2000, they are developing a sort of human assistive device elderly people or handicapped people. So in the almost final stage of the development, they, of course, finally they need to use real human, but they asked us to use our robot in order to mimic elderly or handicapped people, a sort of human simulator using our human. You can see, and also human robot, for example, has many sensors inside. There are a lot of important data if there is a failure. And if human is doing and fail, maybe it's a big matter. Maybe elderly people cannot wake up from the bed forever. And we have a department of human science, and we collaborated with them. They have a lot of data, handicapped people like this. So we transfer the data to Guardian 2 like this. And also, nowadays, we have a lot of simulators. It's a very good simulator. We also transfer to simulator. So this is important. Usually, there are some specialists making devices for each handicapped people. But this may not be perfect. So we can test the mechanism is useful or not dangerous for each handicapped people. And also this is a big challenge. One day, mayor of Fukuoka City came to my lab and he asked me, we wanted to apply to the government to change our law, especially the traffic law, because under Japanese law, only definition is cars and the pedestrian, no robots. So they never allowed us to make the robot walk on the street. So, but we are very fortunate that one politician, that of course, police department strongly opposed. we don't want to more things that may cause some accident. But because of politician, he said, "Oh, it's okay." Then the Japanese law changed. Nowadays, you can do this kind of experiment anywhere in Japan. And we also apply the change of, give us roboticists a certain bandwidth of a radio wave. Nowadays you are using Wi-Fi, but it's shared, many people. Sometimes collision and lower bandwidth of communication. But if we have a especially robot band, that's much better for us to do robotics on the street or outside. So because of this, by the way, I was born in Fukuoka City, and I am a vice president of some technological organization of the prefecture. And then the prefecture had a kind of special district for robot experiment. And we did a lot of experiments, not only us, but also other robotic companies, mainly located in Fukuoka City, Fukuoka prefecture. This is the World Robot Declaration. By the way, in this declaration, Mark Rabert, Boston Dynamics, he was a professor of MIT, and we are very good friends from the year 1984. he came to Fukuoka and joined us to give this kind of declaration. And this is also international collaboration with European researchers. This is Paolo Dario, famous robotic scientist, and right hand me. And the second one, Alain Berthaud, he's a brain scientist. He has a lot of hypotheses about brain. So he wanted to realize his theory, not by using human, but by using human code. So there is a Roboson project and the project FP7. And we not only inside the university, but also we have been giving a lot of our technology to outside companies. Temsa, Sanyo, unfortunately, the company bankrupt. Many Japanese organization and ZMP still working. And Temsa still collaborating with Sony like this. And human technology also useful for disaster. Just before the pandemic, COVID-19, I involved in the Japanese national project called IMPACT. One of the projects is called Tough Robotics Challenge. We developed this kind of human robot. Not the human, but the sort of multi-modal robot. 4-legged walking, 2-legged walking, and walking up down the ladders, and like this on the garbages, like this, and especially walking on the garbages. This robot carries this kind of armor on the body. This is not much reason. Another thing is the actuator. We cannot find in the market, so we finally decided to make design and produce in our university. But Mitsubishi Heavy strongly helped us to realize this kind of actuator development. Okay, last July, we press released the new organization called KYOHA. That stands for Kyoto Humanoid Association. Kyoto has a lot of high-tech companies, maybe Nintendo. Yeah, not only Nintendo, there are many numbers of companies. Temsa also located now. Before Fukuoka, they moved to Kyoto. And Murata and Kayaba, there are, of course, not limited in Kyoto, but also many other areas of Japan now. Still, many companies are asking us to join. So maybe next time, maybe the beginning of next year, we are going to press release again. Mabuchi Motor. Many people believe that Mabuchi Motor is a motor company for toys, but it's totally not true. Most of the cars use the Mabuchi motor, for power window, opening the door, wipers, and voice copiers, printers. Most of them are made by Mabuchi. Mabuchi now goes into the humanoid market for actuator development. And of course, we are planning to make a disaster capable in the future. Kayaba is one of the famous Japanese company on hardware system. And Hephaestus, this is a very unique company, making world #1 precision bearings, including ちゃう。中体式別に英語でなんていうの。Okay. 3D. Yeah. This is one of our tutorials. Almost every day, mails are going back and forth among us. By the way, I showed you the teaching robot, but the original idea was this: the hopping robot using a spring that makes the robot to be much less energy for movement by Professor Takanishi. And he now developing more human-like running robot like this. And also, this is a collaboration with Tenzan. Actually, this is a bipedal walker carrying a human. This robot itself weighs about 65 kilos. But this robot can carry up to 80 kilograms humans up to its upper body. And in the year 2007, the city of Los Angeles invited us to display, not only display, to demonstrate carrying a human like that. By the way, this is a mayor of Los Angeles. I don't know if he is continuing the mayor, maybe not. ABC TV reporter and kids, small kids, big kids. Because this robot can measure the human, then change the walking motion according to the change of the dynamics of the robot. By the way, I was very nervous when I had a request, because if the robot fall down, then that's maybe my researcher's life will end. But they say, okay, it's just the right sign. If there's a small kid, okay, parents can sign if there is something happen. And also they okay, insurance. They say it's okay. We have put a large insurance. But about 2 weeks, I was very nervous. But until the end, there was no accident caused by the robot. And this is a musical humanoid robot, the Lee Sensei's project team. You can see here, this is a human-like mechanism using diaphragm. That robot needs to breathe while playing the flute. You see? So this robot, you give the musical score, MIDI data. MIDI data now is a sort of digital score. So by using that data, the robot automatically generate optimal breathing point while playing. And the most important thing is the mechanism of the hips. You can see each of the changes the robot precisely changes the shape of the hips. By the way, a professional flautist told me that this play cannot be done by you. So the speed is too high, change of the note. Then one day Toyota came to my house and let's do collaboration, the musical robot. not flute player, but saxophone player. So we collaborated with each other. And also they requested us, strongly requested us, if possible, would you like to put that upper mechanism on the lower mechanism made by Toyota, meaning that there will be no space for the lung mechanism like the flute playing robot. So we finally decided to develop a very small compressor for saxophone player. By the way, at the same time, one guy from Germany came to the lab and finished the master of English. And he's a very good saxophone player. So good musical player makes a good musical robot. Now he's running mainly sensing, small sensor, IMU sensor company in Japan. And almost in the night of Friday, he's a disco. Very high contact. Okay. This is also related to the flute playing robot, but this robot is a speech production robot. One day I had a phone call from MTT research group. Let's make a speech robot. But I asked them, why? Now, small device can speak anything. Not Japanese, but by English, anything, Taiwanese. So they said, no, this is, we wanted to know how human generate human speech in terms of mechanism. There are a lot of simulation, but simulation cannot be so reliable because there are a lot of hypotheses, boundary conditions that human put. So they want to compare their computation model with a real speech production robot. So this is a mechanism that we designed. Okay, I'd like to show you speech production. Japanese vowel, aiueo. Can you hear? Sashisu says so. Japanese consonant. In this case, the robot needs to have a teeth. Nanimune no nasal cavity is important. Papipupepo, air tightness is also important. And this is continuous IUAO. So very difficult to listen because of the spectrum goes to the lower frequency. And some researchers in the dentistry told me, why don't you drink something? So we try to do that. This is swallow. This is drinking. This is oolong tea. Chinese tea. And then also we collaborated with my university, a huge university, having more than 60,000 students. And we are accepting the largest number of Asian students in Japan, more than collaborated with psychologists in the different school of literature. They helped us a lot. So this robot has many sensors and actuators on the head part. I don't have enough time to explain in detail, but you can see so many sensors and actuators like this. So the important thing is this. How do we control the emotion? So in mechanical engineering, equations of motion, this is a basic equation to define. This is a starting point of education in the university. Okay, not only Taiwan, Japan, but also all over the world in mechanical engineering. So I had an idea. Maybe equation of motion can be used for emotion change. So we call it equations of emotion. Then change the coefficients like this and the variables like this. And this is a simple explanation how this works. So we employ 3D space for human mental space. Arousal, sleep, present, unpleasant, certain, and uncertain. They teach us a lot how to modelize. Of course, they are not so familiar with mathematics or physics, but there are a lot of papers which makes us have new idea. So depending on the stimuli outside, the trajectory changes. Okay. And this is the area. For example, in the red area means happiness, orange, anger, blue, dark blue, disgust, fear, light blue, or something like this. So this is the basic mechanism, how this robot changes the emotion depending on the stimuli outside or international condition. So I can show you some data. On the right hand side, this robot is seeing the green ball. Whenever see the green ball, the robot experience good thing. Robot always become happy. And also there are two microphones, almost the same part of the human ear, and that can localize. So whenever robot sees the red ball, robot was hit or something, but the robot will smell the alcohol, in this case vodka, robot becomes drunk, then expressing the happy face. But this robot also has a lung. In order to continue, while continuing the breathing, the robot becomes serious again. Then get angry. And some strange face like this. And then we had a lot of collaboration and hypothesis about we call it mental dynamics. The robot mechanism itself is moves like human. Otherwise, the human communicating with this robot doesn't have a feeling to this robot can do like this. And then after that, we combined the Wabian 2 and the emotion expression robot to Korean. Why I wanted to do this? This is a year of Japanese big tsunami. So more than 2,000 people killed by direct by tsunami, and 200,000 people also affected by the tsunami. And I helped the people in the area of seashore, Minami Sanriku and Rikuzen Takata. In the Minami Sanriku, I saw a lot of small kids who lost parents and his daughters and brothers. So one of the teachers who survived asked us to make them happy, if possible. So I went there several times to give a speech and show this kind of presentation. And one of my PhD students makes this kind of podium to make people laugh.
続きまして、びっくりした瞬間のマスオさん。
Short time gap. サザエさん。This is called short time gap. And because this robot can move the legs very high. Okay, this is a theater robotics I call. And one day, theater director came to me and please teach us how to make robotics mechanism for theater play. Because they have a special privilege to play Osamu Tezuka, who is in Japan at least, thought that he's a god of Japanese manga. And one of the famous masterpieces of his manga is the Blackjack, related to medicine. The Blackjack cannot be easily played because there are a lot of strange shapes or some kind of biological cyborg or something. So we accepted one team member of the theater group, and my student also helped them to develop some kind of robotized mechanism for the theater play. And this is Mr. Kudo, who is the producer of the theater group, Human Arts Theater. You can see they are very good at making rubber mechanism, putting color making. But unfortunately, they are not good at making robotic mechanism. So we taught them how to design the. Most of the play can be not automatized, but controlled by radio wave. So they are doing theater play by this kind of strategy. But I think that's good. So play by play, maybe the motion changes. Okay, now my laboratory is mainly located in this building for twins. This is a very unique building. My university, Waseda, and the neighbor university called Tokyo Women's Medical University built collaboration building like this in the year 2008. And then we did a lot of medicine-related research. By the way, my research history, medicine-related one is this. This is a chewing robot requested by the dentist people. By the way, this mechanism is not the plastic one, the real human skull taking out from the human dead body. We put the actuation mechanism. Then they want to measure how much deformation made while chewing something. So this is a simple demonstration video. At that time, there is no saliva or tongue mechanism. So we put in the liquid or thin plastic bag, and then the robot chewed. But the result was very interesting. We even had an award. And then one day, then another researcher in dentistry came to my lab. How about making a robot which treats the patient who had a jaw joint problems, temporomandibular joint disorders. Have you ever heard about this? And usually, medical doctor put a big scissor-like mechanism in the mouth, and then put the rubber band on the end point, then just open the finger. That was a big pain on the jaw joint, so almost useless. But using of compress control, the robot opened the jaw while making the reaction force to the jaw joint becomes minimal. Sorry. I have a wrong video. But anyway, we succeeded a lot of medical treatment for the jaw joint problem. And then one day we had the idea that robot control, we do our best, we did our best. But if it is also safe for the patient, we are not sure. Even though doctors say it's good. So we had the idea to use the chewing robot as a human patient simulator before putting the applying to the real human. So we had a patent that still gives me a patent. So this, the human robot can be, in this case, dentistry, used for many purposes. First, testing of current devices, and invention of new devices, and the new treatment, and the education. So there is a computer recording all the data in between. Then the robot mimics the skilled doctor's treatment. So we had a collaboration with Kyoto Kagaku. Also, Kyoto Kagaku is the number one biggest company producing of medical teaching parts for educating, I think, Taiwan too. Brain, heart, many internal organs, many parts of the body, it mimics those parts. Because it is almost impossible to see everything while in the medical department. So, and they want to have a mechatronics department in the company. So they sent us several young engineers. So we taught them how to design those mechanisms for mechatronization of their devices. This is one example for suture and ligature after the end of the surgery. Nowadays, most of the device, of course, you can buy, but no sensors. So you cannot confirm that your technique is okay or not, unless there is a skilled medical doctor beside you. But this system gives you the number from 0 to 100 on the suture and ligature. So that's a big savings for them. You can check accessing their website. This is a teaching video of the device. And after that, we had a new project. A sort of upper body human, or airway management. This is a lot of cases in traffic accidents, and surgery. Many cases, the patient needs to have an airway between the lung and the outside. But there are a lot of accidents occur because of the unskilled people. So we put a lot of sensors that mimics the airways, like human. And also a lot of medical doctors. Do I have a time, or do I need to finish my time? 3 minutes? Okay, thank you. They helped us a lot how to improve. When they have a time for 10 minutes or 20 minutes, they came to my lab just beside the hospital, the twins, the building. So we finally built up the prototype. And then we gave it to Dr. And they finally finished the marginalized one. You can see also there. And this is also another collaboration. Tenza. This is a dental patient human. We collaborated with Showa University and Kogakuin University, where one of my alumni, Professor Takanobu, now he became a professor. And we collaborated each other to develop this kind of patient robot with STEM. So you can use a real dental treatment tools like this. And there are several sensors inside. And also, the robot is totally self-controlled. Because this demonstration is being done based on OSCE. Maybe medical department people here. OSCE is now worldwide. The standardization for medical treatment. So the doctors told us that not so highly AI is not so important because it's already standardized. And we also developed a newborn baby type 1, like this. Okay, this is the end of my talk. Thank you very much for your patience.
Thank you, Professor Takanishi, for the so many amazing robots. Because of the time limitation, maybe we can take one question here. Any question from the audience here? I'm curious about you mentioned about the equation of emotion. Can you really think we can formulate human emotion in a second order linear equation?
I don't know, but this is a starting point. I thought. But we did a lot of interaction experiments with mostly young people. But they say they never complain about that. So if you hit, the robot becomes angry or something. That's standard. By the way, you can. There is a table inside. You can change the coefficient to different type of sensing. So if you hit the robot becomes happy. So this is also very important. This can realize the difference of personalities, including abnormal ones.
Thank you much. We have some gift for our distinguished speaker here by our director, Lee. Your time.
Wow. Okay.
So listen.